In today's video, we'll draw the reaction mechanisms of a Hoffmann elimination versus a Hoffmann rearrangement. So the Hoffmann elimination is you have an amine, but you decide that you want a different alcohol from this amine. Whereas for the Hoffmann rearrangement, you start with an amide and you turn it into an amine, but you also take away that carbonyl carbon. So we'll do the mechanisms here. So in Hoffmann elimination, we start with an SN2 reaction. So whatever alcohol you want to add onto your new amine, you make that an alkyl halide and do an SN2. So that will give the NH2 a positive charge, which makes it an awesome leaving group. And it is based on this leaving group that we get our new product through the E2 elimination of the beta carbon. And this reaction happens in base. This becomes our leaving group. So then we create an alkene plus the new alkyl, but with the new alkyl on our amine. So that relies on this as our leaving group. For Hoffmann, the amine is also a leaving group, but there are a few steps. But all of these steps begin with adding a negative charge on the nitrogen. So the first step here is we want to put a negative charge on nitrogen, and this reaction happens in bromine. So then we can, hold on. So we have to deprotonate this before we can add a bromine. The first step is the N-bromination of the amide. So that gives us a nitrogen anion, which can then attack the bromine. So that's the first step. The second step is we want to put a negative charge on the bromine once again. A negative charge on the nitrogen once again. But this time we want the product to be an isocyanate. How we do that is notice that N and R are connected, whereas here the R group's connected to the carbonyl carbon. So what we can do is this bond will attack it here, and we don't want this bromine anymore, so we expel bromine, and we want a double bond between nitrogen and carbon. So we put this lone pair on the nitrogen here. So that will get us an isocyanate. This is a carbon. Okay. Last step is we take this and we will once again make an anion of this nitrogen, which will happen thanks to the base once again, who will attack the positive carbon, and we want to push this bond on the nitrogen because we want to start doing whatever it takes to eliminate that nitrogen. Okay, so that will give us an N. So once again, we have this pattern that the first step of each of these three steps is such that we form an anion with the nitrogen. And now we want to make this as positive as possible because that will give us the leaving group that we want. So we can do a proton transfer. So you just imaginarily pluck this OH off and then put it on the N, even though that's not actually what happens. But this becomes neutral because it was negative. But we want it to be positive so that it can be a good leaving group. And luckily we have some water in our solution. So now we will be able to protonate this with a positive charge. And we can then expel this with this negative charge coming down and pushing out our leaving group. So that will give us some carbon dioxide and also our new amine. Okay, so major takeaways is that in both of these reactions, the amine is a leaving group. But in the Hoffmann rearrangement, each of these three steps start with a base attacking the hydrogen, and that will put an anion on our nitrogen. Okay, so that's the same thing. Same thing happens for all of these three steps. Then the only difference is that the nitrogen anion will do different things. In the first step, it will attack bromine. In the second step, it will add an alkene and then push things around to give an isocyanate. And in the last step, there's a proton transfer and then attack of water to fully protonate the amine so that it becomes a good leaving group.